Let's take a look at vertical asymptotes. Vertical asymptotes occur if when my function approaches a certain x value from one side, the y values approach either positive infinity or negative infinity. So let's take a look at a graph. Here, when my function approaches x equals 0 from the right-hand side, we can see that the y values skyrocket upwards and approach positive infinity. And as my x values approach 0 from the left-hand side, we can see my y values skyrocket downwards towards negative infinity. This leads us to think that there's an asymptote at x equals 0. Now let's look at a more formal definition. There's a vertical asymptote at x equals a if the limit of my function as it approaches that x value from one side is either positive infinity or negative infinity. My function doesn't have to act the same way on both sides of the asymptote. So when I'm approaching my asymptote from the right, my limit could either be infinity or negative infinity. And when I'm approaching my asymptote from the left, again, my limit could either be infinity or negative infinity. Let's look at an example of a function that doesn't act the same way on both sides of the asymptote. If we look at this graph, when my function's x values approach x equals 0 from the right, my function's y values approach positive infinity. But when my function's x values approach 0 from the left, my function's y values approach negative infinity. Of course, we could also have functions that act the same way on either side of the asymptote. Let's look at an example of that. So on this graph, we can see that as my x values approach 0 from the right, my y values approach infinity. And the same is true as my x values approach 0 from the left. My y values also approach infinity. So we can see that when we're finding vertical asymptotes, we should check the behavior of my function on both sides. To do this, I'm going to have to use one-sided limits. Let's take a look at how. The first thing I want to do is find out what x value makes my function's denominator equal to 0 after I've factored out the function as much as I can. If a is the x value that makes the denominator 0, then the vertical asymptote is the vertical line x equals a. But when my function's x values approach a from one side, we don't know if its y values approach positive infinity or negative infinity, and we're going to need to know which one it is. Here's one thing to keep in mind. Remember that if I have 1 over a very small positive number, like 1 over 1,000th, that's going to give me a big positive number, like 1,000. So 1 over an extremely small positive number will be approximately positive infinity. And I call this extremely small positive number 0 plus. Now, 1 divided by a very small negative number, like negative 1,000th, will give me negative 1,000, or a very big negative number. I call the very small negative number 0 minus, so 1 over 0 minus will give me negative infinity. This is going to be important later on. When we take the one-sided limit, we just need to figure out if, when we plug in my a value, it makes my denominator a very small positive number or a very small negative number. That'll determine whether I'm approaching positive infinity or negative infinity. Now let's take a look at the steps. First, factor and simplify my function as much as you can. Next, we're going to find the x values that make the denominator equal to 0. Then we're going to take the limit of my original function as it approaches these x values, and we're going to have to do that from both sides, using one-sided limits. Let's go straight to the example. Right now, I have y equals x plus 1 over x squared minus 1. So when I factor out my function, I get 1 over x minus 1. It's clear that my denominator is going to equal 0 at x equals 1. So now I'm going to take the limit of my original function as x approaches 1, and I'm going to do that from both sides, starting with the right side. When I take the limit of my function as x approaches 1 from the positive side, what I want to do is imagine that I'm plugging in a number that's slightly bigger than 1 into my function for x. So first thing I do, as usual, is I simplify my function. So I have the limit as x approaches 1 from the right of 1 over x minus 1. And now that I've simplified it as much as I can, I'm going to plug in the number I'm approaching, which is a little over 1, or 1 plus. Now, when I plug in 1 plus for x minus 1 becomes 1 plus minus 1. And since 1 plus is slightly bigger than 1, then I'm going to have a very small positive difference, which I call 0 plus. Now since 0 plus is on the denominator, I know 1 over 0 plus is going to give me a very big positive number, or infinity. That's how I got that the limit from the right side approaches infinity. Now let's test it from the left. So again, we simplify my function until we can't anymore. So now we have 1 over x minus 1. I plug in 1 minus for x. Remember that 1 minus is slightly less than 1. So now when I do 1 minus 1, I have a number that's a little below 1 minus 1. So that's going to give me a very small negative number, 0 minus. 1 over 0 minus will give me negative infinity. So as my x values approach 1 from the left, my y value is going to approach negative infinity. So now I know how my function behaves on both sides of the asymptote. Now let's make sure it makes sense with the graph. Going back to our graph for x plus 1 over x squared minus 1, we can see that as my x values approach 1 from the right, my y value approaches infinity. And when my x values approach 1 from the left, my y value approaches negative infinity. And this confirms what we found.